When it comes to the universe itself, perhaps no better views have come, ever, than those from the Hubble Space Telescope. Across a myriad of objects, Hubble's eyes have shown us the universe as we've never seen it before. Here are 20 of its finest moments. The Pandora Cluster, known formally as Able 2744, is a cosmic smash-up of 4 independent galaxy clusters, all brought together under the irresistible force of gravity. Image credit, NASA, ESA, and J. Lotz, M. Mountain, A. Kokimoer, and the HFF team. Galaxy clusters, the most massive bound structures in the universe, these contain anywhere from a handful up to thousands of Milky Way-sized galaxies. From incredibly deep views in space to bent light by their gravity, to individual galaxies speeding through them, Hubble offers views like no other. When there are bright, massive galaxies in the background of a cluster, their light will get stretched, magnified and distorted due to the general relativistic effects known as gravitational lensing. Image credit, NASA, ESA, and Johann Richard, Caltech, USA. Acknowledgement, Davide De Martin and James Long, ESA, Hubble, NASA, ESA, and J. Lotz and the HFF team, STSCI. The Hubble Ultra Deep Field, containing over 10,000 galaxies, some of which are clumped and clustered together, is one of the deepest views of the universe ever taken, showcasing a huge stretch of the universe from nearby structures to many whose light has traveled for over 13 billion years before reaching us. Image credit, NASA, ESA, and S. Beckwith, STSCI, and the HUDF team. This spiral galaxy is leaving a wake of stars, dust, and gas, as it plows through the intra-cluster medium of its home galaxy cluster. The space between these galaxies isn't completely empty, and that's what causes this incredible effect. Image credit, NASA, ESA, and the Hubble Heritage Team, STSCI, Aura. Individual galaxies, whether shaped like spirals, ellipticals, or anything in between, the gas, dust, stars, powerful black holes at the center, and brilliant, pink, star-forming regions highlight these cosmic, island universes. This galaxy has a glowing heart because it's a special type of active galaxy, a Seyfert galaxy, whose central black hole is presently devouring matter and emitting light at a higher temperature and luminosity than all the surrounding regions. Image credit, Space Scoop, ESA, Hubble and NASA, DCalZE, UMass and the LEGU.S. team. This unusual galaxy is part-way between the evolution from a spiral to a lenticular galaxy, containing both an enormous central bulge and the classic dust lanes associated with a spiral. Over time, if more major mergers occur, this will become a true elliptical. Image credit, ESA, Hubble and NASA. This galaxy, like a great many, appears dustier on one side than the other because of how it's oriented with respect to our line of sight. The galaxy is tilted towards us where the dust is most prominent, and away from us where it's most obscured by the brilliant starlight. Image credit, NASA, ESA and W. Harris, McMaster University, Ontario, Canada. The Whirlpool Galaxy M51 appears pink along its spiral arms due to a large amount of star formation that's occurring, triggered by an interaction with another nearby galaxy. These pink colors come about because of ionized hydrogen, caused by the heat and UV light from newborn stars formed in these regions. Image credit, NASA, ESA, S. Beckwith, STSCI, and the Hubble Heritage Team STSCI, Aura. Nebulae, originating when gas either collapses or gets shocked and heated, these dense configurations attempt to give rise to new stars, while the surrounding environment works to boil the gas off. The race is on. As a massive, hot, central star burns through its fuel, its radiation pushes out against the gas-rich interstellar medium, working to evaporate the star-forming gas away and quench this ongoing process. Image credit, NASA, ESA, Hubble Heritage Team. The Eagle Nebula, famed for its ongoing star formation, contains a large number of Bok globules, or dark nebulae, which have not yet evaporated and are working to collapse and form new stars before they disappear entirely. Many of these last remnants will fail, instead leaving only mass clumps and failed stars behind. Image credit, ESA, Hubble and NASA. On the other hand, some Bok globules already have young stars inside of them, like this spectacular caterpillar-like conglomeration in the Carina Nebula. Image credit, NASA, ESA, N. Smith, University of California, Berkeley, and the Hubble Heritage Team. STSCI, Aura. The pillars of creation in the Eagle Nebula are some of the most famous, and most spectacular, dusty regions of a star-forming nebula ever captured by any telescope anywhere. Image credit, NASA, ESA, Hubble and the Hubble Heritage Team. Individual stars, whether newborn, middle-aged, or a dying corpse, stars are the building blocks of everything that makes the universe what it is. This dense collection of stars is what you see when you point Hubble towards the galactic center in a relatively dust-free region. Some of the stars appear redder in this image than others, and this is not always due to their intrinsic color, but rather to the amount of dust in between us and the star, along that particular line of sight. Image credit, ESA, A. Calamita and K. Sahu, STSCI and the Sweeps Science Team, NASA. The largest group of newborn stars in our local group of galaxies, Cluster R136, contains the most massive stars we've ever discovered, over 250 times the mass of our Sun for the largest. Over the next 1 to 2 million years, there will likely be a large number of supernovae to come from this region of the sky. Image credit, NASA, ESA, and F. Pareshi, INAFIASF, Bologna, R. O'Connell, University of Virginia, Charlottesville, and the Wide Field Camera 3 Science Oversight Committee. Ultra-hot, young stars can sometimes form jets, like this Herbig-Haro object in the Orion Nebula, just 1,500 light-years away from our position in the galaxy. Image credit, ESA, Hubble and NASA, D. Paget, GSFC, T. Megeith, University of Toledo, and B. Raperth, University of Hawaii. This image of the Crab Nebula's core, a young, massive star that's recently died in a spectacular supernova explosion, exhibits these characteristic ripples due to the presence of a pulsing, rapidly rotating neutron star, a pulsar. Image credit, NASA, ESA. Planetary nebulae, every star will someday die. These stunning visual examples highlight what might happen to our Sun. When seen from a certain orientation, this donut-shaped nebula, known as the Ring Nebula, provides a possible example of what our Sun might become approximately 7 billion years from now, when it dies in a planetary nebula. Image credit, NASA, ESA, and C. Robert Odell, Vanderbilt University. This planetary nebula may be known as the Butterfly Nebula, but in reality it's hot, ionized luminous gas blown off in the death throes of a dying star, and illuminated by the hot, white dwarf this dying star leaves behind. Image credit, STSCI, NASA, ESA, and the Hubble SM4 Aero team. The Red Spider's Nebula, shown here, has ripples and shock waves throughout its gas, due to the ultra-high temperature of its parent star, one of the hottest stars to form a planetary nebula in the known universe. Image credit, ESA and Gerald Mellema, Leiden University, the Netherlands. Finally, the Twin Jet Nebula shown here is a stunning example of a bipolar nebula, which is thought to originate from either a rapidly rotating star, or a star that's part of a binary system when it dies. Which one of these, if any, will our Sun someday look like? We're still working to understand that. Image credit, ESA, Hubble and NASA, acknowledgement, Judy Schmidt. Mostly Mute Monday highlights the astronomical wonders of the universe in images, visuals, and no more than 200 words. Starts with a Bang is now on Forbes, and republished on Medium thanks to our Patreon supporters. Ethan has authored 2 books, Beyond the Galaxy, and Treknology, The Science of Star Trek from Tricorders to Warp Drive.